the other way that they said you could produce electricity without using a battery? What was it, Danny? A generator. Generators they can use, in this picture they used water flowing over a waterfall that spins something called a turbine, which turns a giant magnet between a coil of wire, and we get the flow of electrons. I wish we could show this. We've tried and tried. We don't have powerful enough magnets to force the flow of electrons. I'm going to ask Mr. Lazarewski if he can get me a stronger magnet so that I can show you what a generator really does. For today, you're going to have to take my word for it, that if we take giant magnets and put it through a coil of wire, we can get those electrons to flow. Very good, you remembered. On the next page, what? Do you? Maybe you can bring it in. Is it powerful?
Yes.
Good. If Mom or Dad will say it's okay, bring it in because we've got plenty of wire. We can try to make our generator so you know how it works. Turn the page. The next page you see something that you're very, very familiar with. That's a magnet, right? Or it's called magnetism. What I want you to do is I want you to look carefully on that page, and I want you to read that page to yourself and explain how those iron filings are showing the magnetic field. So you need to read that page to yourself. What do they mean by a magnetic field? What do you think they mean? We have a magnet. We've talked about magnets. Who can tell me about a magnet? What do I know about this? Adam, give me a fact.
It sticks to metal.
All right, good. It's going to stick to metal. What else? Tell me something else.
North sticks with south.
North sticks with south. What else?
Steel.
It sticks to steel.
Sticks to iron.
Iron.
And if you put it north to north, it won't stick.
It won't stick if you put like poles together.
Don't put this certain thing on it and lose all its electrons and you won't be able to use it anymore.
Very good. All right. This is a very special kind of metal. It's been what we call magnetized. Remember, we have a north and we have a south. And yes, we need the electrons to flow through all the time so we don't end up having a problem. Now, in the book, they said they put a magnet down and then they showed you a magnetic field. What are they talking about? When you look at the picture, can somebody tell me, what are they saying when they say that's the magnetic field? What are they talking about? Jimmy?
Like a certain area that attracts stuff from certain area.
Very good. Let's see if I can create a magnetic field up here on the overhead. What I have is iron filings. In other words, they've just taken up some pieces of nails or iron and cut it all down, and it looks almost like pepper. You want to be careful, though, that you never get this on the magnet, because it's hard to come off. Am I creating the magnetic field like what you have in the book? Yeah, that's right. Okay, the magnetic field is where you see the iron filings doing what? What do you think? What are they doing, Sean?
They're attracting it.
All right, good. That's a good way to say it. You're kind of attracting it. If I take a look at this part out here, can you see this part out here? You may want to hide it. Out here around the edge, are those iron filings doing anything other than just sitting there? How many people think they're just sitting there? How many people think that they're doing something? How many people think that they don't know? Take a look at it. Here, do you see these iron filings doing something in that section? Can you see how they're definitely kind of being pulled one way or another? When I go out here, are the iron filings being pulled anywhere? Or are they just kind of sitting there? Take a look out there. Do they think does it look like they're being pulled one way or another? Or they're just sitting? They're just sitting there, aren't they? That's because those iron filings are beyond what we call the magnetic field. There is no pull out there. The iron filings cannot feel that. Right? It's out of its reach. Almost if I went outside and you people were playing outside, and suppose you were right on the swings, and I came out here and I yelled really loud and said, "Time to come in." Could you hear me? Maybe. How about if I'm out there and I yell and blow my whistle really loud, will you hear me if you're at those swings? Yes. So that would be being within the magnetic field. However, suppose 4 of you go over to the high school, and you're out behind the high school, and I stand here and start screaming for you to come back. Are you going to hear me? I don't think so. That's the same thing that's happening with these iron filings that are outside. They're too far away to be feeling that attraction. They can't feel that pull. But these iron filings that are right here, they're close enough, they feel it. Now, what can you tell me is happening at the poles? First of all, where are the poles? Roger, where are the poles? Good, at the two ends. Notice what's happening at the two ends. What's happening? Adam, what's happening?
They're attaching.
Good, they're attaching. They're being pulled. These iron filings up here are being pulled to this end. These iron filings down here are being pulled to that end. Does that look like the same that's happening in your book? Look on page 160 in your book. Does it look the same? Do you see how it's being pulled to one end? Put your finger on one end so I know that you know what I'm talking about. Wrong page height. Okay, now put your finger on the other end. You see how the iron filings are being pulled to either one side or another. Now, look at the middle. Look at this middle here. What do you think's happening in the middle? This sometimes happens to people too. Jesse, what do you think's happening in the middle?